and gentlemen, to another one of these, soon to have a new title, a new name, um, podcast. We're leaning towards something, but and maybe you guys can help us out. But science dum dums kind of describes a little bit, but also it's for me it's always been a little bit weird. But anyways, um, we are two individuals who talk about science stuff
Mm.
from the perspective of amateurs, people who know very little about this stuff, trying to understand science, trying to understand physics a little bit more. I'm a big fan of physics and science overall, but physics in particular, and Richard knows things as well. Um, Usually, we like to start off with correcting ourselves from previous episodes, and I dropped the ball. I didn't do any fact checking whatsoever. So I hope we didn't say anything completely wrong. I don't even remember what last week's episode was.
Um, I have it here. Hold on.
You have fact checks?
No, I don't have any fact checks, but
Ah,
you know my schedule. Yeah.
what was it called? What was it called? Here, I'll grab it real quick. I don't.
Talking about evolution, not just biology.
No, okay. We were talking about the universe learning,
Yes.
and it learns. And this is why I didn't do fact check. Aside from lazy and I prioritized other things, the reason I prioritized other things is because that is more of it's there's no facts behind it. It's just a thought. People that are just experimenting with it. There's no real proof. There's no real science. There's no concrete anything. So anytime we have a subject like that, now I remember what we talked about. Every time we have a subject like that, it's almost pointless to do any fact checking because there
Mm.
are no facts. It just they're mostly hypotheses. And yeah, now I remember why I didn't prioritize it.
It's
Not
my weirdness, my opinions.
say what?
It's usually my weirdness and my opinions.
Oh, it came out.
Dude.
I was trying to hold back that sneeze and didn't work out. Yeah, and this episode is another one of these continued down the path of your weird brain and the weird shit that you like to talk about, which is fascinating, and I appreciate because it's not the stuff that I like to talk about.
Yeah.
So in science, I think you need to be open to this idea of exploring outside of stuff that it is not your interest. It's not what you like to do. So for me, it's been a good thing to talk about stuff that I'm not particularly fond of or interested in. Um, so yeah, that's good. What are we going to talk about today?
We're basically talking about the vacuum of space and why there's actually something where you would think that there's nothing.
Okay,
So we call that the Casimir effect.
the the Casimir
Yeah,
Casimir. So I've
Casimir.
got um I've got to confess that I did zero research on this. Not very familiar with this concept, with this idea. But here is the Casimir effect. Let me see if I can blow this up a little bit more. Eh. Um, the the Casimir effect. I've got the screen over here, so I'm gonna be weird for you guys. The Casimir effect is a physical force arising from quantum vacuum fluctuations, causing two uncharged parallel metallic plates in a vacuum to attract each other. Predicted in 1948 by Hendrik Casimir, the phenomenon demonstrates that empty space is filled with virtual photons, creating higher pressure outside the plates than inside, forcing them together. Um, Wait, so We see this here on Earth, though, and it may not be the same thing, and maybe I'm talking about something completely different, but I actually just seen. I'm gonna stop sharing this really quick. Um, I actually just seen, and again, it may not be the same thing because I know nothing about this, but there is a bowl, I guess, if you will,
Mhm.
and somebody was blowing up a balloon inside the bowl. Now that bowl had a hole on the opposite side, so the hole where um, imagine a 2 liter bottle of soda, and then on one end, the top end, you would place a balloon inverted so that when you blow it up, it fills up the space of the where the liquid would be, um, and then you have a hole on the opposite side. If you do not plug that hole, you blow up the balloon and it deflates. But if you were to blow up the balloon and then cover up the hole, the balloon stays inflated. And it
Mhm.
has to do with the creation of a vacuum. Now, again, I don't know if this is what they're talking about. I don't know if that's what is at play here, but it seems like it would be something similar to that. Um, you're basically adding, again, know nothing about this, but I've seen this in physics before where you get two things together, and because of the pressure on the outside is more than the pressure on the inside, they almost suction together.
Yep.
I guess is that what they're talking about?
That's exactly what they're talking about.
Huh?
So, yeah, they'll move. Two metal plates can move toward each other, um, even when there's nothing between them, just because of the vacuum fluctuation.
Yeah. So key aspects again for those of you guys that are new to this, I'm just doing a general Google search. This is AI giving me a response, so take it for what it's worth. AI for the most part is horrendous at giving factual information, but it is very good at googling stuff for you. So again, take it for what it's worth. Look up the sources, all of that stuff. But anyways, key aspects of the Casimir effect. I'm not even sure if I'm saying that correctly, but it sounds correct. The mechanism, the closely spaced plates restrict the wavelengths of virtual photons that can exist between them, reducing the vacuum energy density inside compared to the outside. The formula is F per area, force per area. The force per area is proportional to 1 over d4, where d is distance, and is described with the formula F over A equals whatever the fuck that is. This is why I didn't go into physics because math is not my forte. Significance: it is a measurable quantum force that becomes significant at the nanometer scale. Experimental evidence, first accurately measured by Stephen Lamoureux in 1996, confirming the existence of this quantum vacuum pressure. Dynamic Casimir effect, the variations occur when a boundary, such as a mirror, is moved rapidly, converting photons into real detectable photons. Crazy. Applications and impact: nanotechnology. The effects causes stiction, a static friction, in micro electromechanical systems where moving parts can stick together. Quantum vacuum exploration. It provides insights into zero point energy and helps validate theories in quantum field theory and cosmology. Innovations: researchers are leveraging this force to create new low power micro switches. Oh, that's interesting.
Mhm.
Go.
Yep. So basically, the way you would describe space is you can remove air from space, you still have space. You remove dust from space, you still have space. You remove light, you still have space. So eventually you assume that you reach nothing, right? But actual physics says that you never quite reach true nothing. There's always something there. There's always some type of activity happening inside what you think is nothing. So tiny microscopic energy fluctuations. That's pretty much what we're describing here, and they kind of appear and disappear, just like static. So it's quiet static, but not quite silence.
What are virtual photons? Do you have that information handy?
Google
Kevin,
does.
what's that?
Google does.
Google does, yeah, yeah, yeah. Google does. Now, is this just with metal though? Because it seems like everybody's talking about metal and nothing more than just metal.
But that was the experiment, so that's what they're referring to. But I believe it does include pretty much any other object.
Well, let's do a quick little. Is the Casimir effect only for metal? We'll do this. Let's do it live. No, the Casimir effect is not exclusively for metal. While historically demonstrated with metal plates, it is a quantum phenomenon that can occur between any two uncharged conducting or dielectric not conducting materials.
Hmm.
Okay, so uncharged conducting or non-conducting materials. Got it. So the metal would have to be uncharged. There'd have to be no static in it. There'd have to be no electricity. So it can't be a magnet.
Right. No magnetism. They have to remove all pressure from the metal. Um, so basically, only vacuum remains.
Huh. I suppose this kind of makes sense even at a logical level where if I mean, but we see this as air for most of the
Mhm.
time. I think most of the time, even the balloon example that I was giving, I think it's an air issue. It's a pressure issue more than it is a because they're talking about photons.
Right.
Um,
Virtual photons.
what are virtual photons? Did you find that?
A transient, non-observable quantum particle that mediates electromagnetic forces between charged particles, like
Oh,
electron repulsion. Hey, we talked about that.
yeah, we talked about that. So because the photons are charged,
Hmm.
things cannot be charged
Right.
because that's what would be creating the charge.
Hmm.
Oh,
It's it reminds me of I guess it's the SAT question where they're talking about two trains that are traveling. No, this is not the SAT question, but two trains that are traveling in parallel. As speed increases, they start to pull each other together, and that's because the pressure between them starts to kind of pull away compared to the pressure that's on the outside of them, or it starts to speed up.
uh-huh. Okay. The Casimir effect relies on conducting metallic surfaces, not non-conductive ones, to act as boundary conditions for because the question that I asked, and maybe I asked it poorly, is why do objects have to be non-conductive? Or that's not the appropriate word. I'm sorry. That is wrong because the metals are conductive, they're just not charged. So
Or
my
yeah,
question is dumb, and this is why we're called the science dum dums. The question would be uncharged.
yeah. So here's a simple version of what is happening in that experiment.
Yeah,
Um, Even when the space between the two metal plates looks empty, there's tiny vibrations that are still happening. Um, they're extremely small. Normally, those vibrations will cancel each other out evenly, but once the plates get extremely close together, fewer vibrations can fit between them than outside of them.
got it.
So, so there's more activity outside of the plates than inside. and so the outside pushes harder than the inside. So it's not necessarily that that the plates are being pulled together. It's just very uneven pushing from the outside.
Very similar. Very fucking similar. Again, it might be the same thing. I don't think so though. But very similar to what I'm talking about. It's just this happens a lot. You do see this when people drop a flat surface, a board, and they drop it on the ground, and you see
Mhm.
it hit, and it kind of glides a little bit because there's still a little bit of air that's kind of stuck in there. Now, the problem with that is that eventually that air dissipates and it's completely gone. Here's what I got from a correct question. Objects in the Casimir effect must be uncharged to ensure the observed attraction is solely due to quantum vacuum fluctuations rather than classical electrostatic forces. Got it. Got it.
Mhm.
If charged, the Coulomb force, which is vastly stronger, would mask the tiny nanoscale Casimir force. The plate must be conducting to set a specific electric boundary. It turns into something completely different if it's charged.
Yeah.
Got it. Because now it's a different effect that's causing them to come together and not the Casimir effect. Got
Um,
Makes sense.
maybe it's polarity turns them. Uh, maybe it's magnetism. I don't know.
Well, no, it can't be magnetism, and that's why it needs to be no the Coulomb force, which we should talk about some other time, unless we have Coulomb force.
Oh, okay.
Coulomb force. I don't know what the fuck that is. Uh,
I've heard this in electronics one time.
Coulomb's law. Coulomb's force is the electrostatic attraction or repulsion between two charged particles, directly proportional to the product of the charge and inversely proportional to the square of the distance between them. Got it. We could talk about that some other time, unless we have some time later on today. But yeah, it would turn into something completely different if they were charged, and also from an experimental or perspective, it would kind of X out this idea that some new force or some new hypothesis is at play when it's
Mhm.
just electromagnetic static. Got it. Makes sense now. Completely makes sense.
So
Isolation. Go ahead.
even simpler. Imagine you have two boats sitting in the water. Um, you have waves that are crashing at all sides of these boats. As the boats start to drift together, the larger waves that are between them can't fit anymore, but the larger waves that are on the outside of them can. So then it kind of pushes them together, the larger waves. It's
Yeah,
the
but there's
same thing.
still water in between the boats.
There's still water between the boats. Yes.
So they won't make contact because there's still water between them.
Hmm.
Um, and because it's pretty water's pretty it can be pretty dense. And it kind of binds together pretty well. That water doesn't move as easily depending on the container that it's in.
Hmm.
Got it. Isolation of quantum effects. The Casimir effect is a phenomenon arising quantum electrodynamics where vacuum energy fluctuates. The force is caused by difference in quantum pressure inside versus outside. So yeah, it's very similar to other stuff in physics. Makes sense. Makes sense. Now they keep talking about this in a vacuum. I wonder why. I guess most everything we experiment with has to be kind of at a vacuum.
Hmm.
Will the
Yes.
boats bump each other, then sever? No, in
I
the
mean, the bow probably will just because of the placement. And that's about it.
yeah, it's one of those where the idea would be. I think a submarine would probably make more sense with this example then, because you'd have to be inside the water for the whole thing to. But yeah, like if it's a traditional boat, if it's an actual boat, the boats are on top of the water. What what the Casimir effect would be is inside technically the water. not on top of it. So kind of like the analogy makes sense, but maybe a submarine would be more. But they wouldn't touch. The idea is there's enough stuff in between where they wouldn't touch.
So then you have applications in real life, things that like for mechanical engineers. If you're designing, say, an engine, you have to have certain tolerances. Um, Say you have your cylinder wall, you have your pistons. There has to be a gap, not just for expansion, heat expansion, but more so because of that same Casimir effect.
Yeah, but that would be. I don't. Would that be the same thing? I don't think that would be the same thing. I think that would just have to do with the friction issue. Now,
Well, yeah.
I did ask why could only work in in a vacuum. The Casimir effect occurs in a vacuum because quantum mechanics dictates that empty space is filled with fluctuating energy and virtual photons. When two uncharged conductive plates are placed nanometers apart, they restrict the wavelengths in a virtual. Yeah, we've talked about that. The video explains how Casimir. Sure. Vacuum energy, 0 point energy. The vacuum is not truly empty, but filled with fluctuating electromagnetic waves. So, I, my only guess right now is if it's outside of a vacuum, you have more stuff at play. So now you're dealing with more.
Well, yeah, you have. Yeah, you're pretty much muddling your experiment, so it
Yeah,
has to be the purest form. Basically, nothing else that can influence.
yeah, yeah. Here on Earth, you'd have all kinds of shit influencing that. Even, I mean, I don't know how crazy this gets, but I'm sure even just cell phone towers and the local the nearby electric panel and all that stuff. So yeah, I got it. So the reason I push back on the engine thing is like I think it would be a good analogy. Like it is a good analogy, but I don't know how the Casimir effect would affect that because this was
Yeah,
first measured in 1996, and we've known about the piston thing for
mhm.
a very long time.
Yeah.
Where
I mean, it's not necessarily just the actual pistons or the design. Is basically how uh, tolerances affect certain metal compounds.
yeah,
So that's basically why engineering you have to account for uh, just another layer of tolerances.
correct. Now it this was talking to when I was looking back. Um, let's see if I go back a little bit more.
And we pretty much discovered the force, I guess, if you were to get take this at a grander scale, right? Star Wars.
I haven't watched those movies.
I've never watched them either.
I've never.
I'm not that kind of nerd.
It just never really interested me. So innovations, researchers have are leveraging this force to create new low power micro switches. So that would be a more practical application. In its simplest form, the Casimir effect is an attractive. Yeah, I think we've seen that. But how are they using it? So there's this article in Physics Today. I'm going to put it up for those of you guys that are interested in how this would affect it. Um, Science and technology of the Casimir effect, and it talks about how it works, the figures, electromagnetic mechanical torsional oscillator sitting on top of a piezoelectric stage is positioned near 100 ohm radius, gold coated sphere. Anyways, you guys can read all this stuff. A lot of this stuff I'm not super familiar with, but they're making better switches is what they're getting at. Um,
I'm wondering what they're using to create the vacuum.
yeah, that's. If we read the whole, if we had time to read the whole article, we'd probably find out.
Yeah.
But I don't know. It doesn't seem like they explain how they do it. Casimir metrology demonstrated microsphere is glued to the platform of a commercial microelectromechanical system, accelerometer, or whatever. Fucking, you know what the fuck I'm trying to say. Using a few picoliters of adhesive, it forms one half of a Casimir cavity. The other half is formed by moving the gold coated electrode close to the sphere. The Casimir force is detected and measured using electronic sensors, the orange, on the accelerometer, which pick up any motion caused by the electrode nudging the movable plate to which the sphere is attached. This device, with all the electronics integrated onto a chip, opens the door to Casimir based metrology. So this is just at a very microscopic level then.
Yeah.
And
Yeah.
I'm wondering if it's because it's so tiny and it's so microscopic that the vacuum or what we're feeling is almost insignificant because you get to a scale where it's so small, any changes or not, it doesn't fucking matter. Like it doesn't matter. An
Right.
example of what I'm trying to give, and sometimes when it's so huge, it almost doesn't matter. And
Mhm.
my example would be a lot of weirdos that don't know about science say that during a full moon, because the tidal force is greater than normal because it's a full moon, because they don't understand how it all works. The
Mhm.
tidal force is a little bit heavier, and therefore people act crazy and all that shit. But if you do the math, the force that fluctuates with the moon depending on where it's at is so minuscule, it has no effects on our lives.
Right.
I think the force is like you set a fucking pillow on your head, and that's the amount of force that you're feeling. It's not enough, and that's just the way they would measure it, right? So it's not enough to affect humans. Like it's all in your fucking head when you think that people are crazy during a full moon. Like it has nothing to do with that.
They're usually crazy all the time.
All the time, you're just paying more attention when
Yeah.
it's a full moon. Um,
Mhm.
so my uneducated guess is this is happening at such a microscopic level, such a tiny, tiny level that it almost doesn't need the vacuum. Now, it could be wrong, but just not big enough.
Or the existence of the vacuum or absence has more of an effect because of it being at such a microscopic distance.
Say that again.
So once you start to remove everything in between the two plates, um, that effect has more, or basically, you're removing those virtual photons, or you're removing um, anything in between the two plates. So it seems to have more of an effect at a microscopic scale than if it was at a larger scale. Say you have the two metal plates are being separated by a wooden chair in the middle, and they're very large. You know, they're not going to ever be able to come together. But then once you take that chair out of the middle, then you can push them together. So the two plates at a microscopic scale, there's something in between them at all times because um, at that scale, you still have particles that are in between them. Once you remove all the particles, which introduces the vacuum, then there's nothing holding them up, holding them apart.
Wouldn't that have an inverse effect though? Because you're removing everything from the center, not everything from the outside. Which I guess you could argue because those particles, and again, I have no fucking clue. I'm just using my logic here, and That's the problem with physics. Sometimes you try and use your logic, and a lot of this shit's so super counterintuitive. So,
Hmm.
anyways, I guess if what you're saying, and I'm thinking out loud here, is because you're saying remove the stuff in between the particles, the photons in between. Um, but then that would bring them closer together, but all at the same time. No, it
Because you still have particles on the outside.
yeah, stuff
Those
has to.
particles are pushing on the outside. You have particles pushing them apart on the inside. Once you remove the particles that are on the inside, the ones from the outside push them together.
Yeah, but the Casimir effect would be that there's still stuff in between those two.
No, there's nothing, just a vacuum. So they remove everything from in between.
No, but I thought the Casimir effect would be that there's still stuff in between and they never really touch. So the
Um,
Casimir is a physical force arising from quantum vacuum fluctuation causing two uncharged parallel metallic plates, or we learned that anything that doesn't have a charge, so wood, it would work as well, in a vacuum to attract each other. Um, but they only attract each other, they don't touch. Um, do let me ask it. Do they touch? So it goes back to my wife's question: is do they touch? Yes. Okay, got it. Yes, the Casimir effect causes two uncharged conductive plates in a vacuum to attract and pull together. While they do not have to touch initially, the force generally pulls them toward each other until they make contact, a phenomenon known as. So we did learn about that, but that's the static friction, the stiction. Got it. Got it. Got it. Got it. Got it. So I was under the impression that there were still wavelengths in between them, and that's why they wouldn't touch. Now we talked about in previous
yeah, like
episodes on how nothing actually really touches at a very microscopic level, but you can watch that episode. Got it. So I misunderstood it. They don't necessarily have to touch, but they also are not prevented from touching.
correct.
This is
So
weird. Physics is weird.
this is weird. Yep. That's the whole purpose of this show, is to show how weird physics is.
How weird it fucking is. There's this interesting article that I'm gonna get rid of my cookies really quick. It says the Casimir effect, a force from nothing. This is from Physics World, back from September 2022. I encourage you guys to read it. Now, I'm not going to read it live, but just skimming through it is super fucking fascinated. Very fascinating. So I guess the nothing is not really nothing; it's just the vacuum.
Correct.
And we've learned that even in a vacuum, it's not that there's nothing there. Just
It's
physics is
you
weird.
can't see it.
Physics is weird. Go to this article. It's called "The Casimir Effect: A Force from Nothing." Again, Physics World, 1st of September 2002. And I imagine that that's a picture of uh, Casimir himself. I would imagine. Doo-doo-doo.
I would imagine too.
Yeah. Well,
So yeah, physics is basically showing us realities actually made of interactions and not actual matter.
okay, say that again.
So it's showing us that reality is made of interactions, not actual matter. And so
This
this,
is where you lose me. This is where you lose me.
I did,
Like it needs to be broken down for me like at a really dumb level. Like I need to hear this a little bit differently. But when we start talking about it's not reality,
Yeah.
my brain goes somewhere completely different. Now, in physics and in science, we say a lot of stuff that is not the way. In science it means something different than in the colloquial world, like if you speak about it colloquially. It just, again, an example, theory in the science world is not the same as it is in layman's world for the lame. So it's, yeah, it's just weird. So I need to study that more. Go, keep
Yeah.
saying your words
I
though.
did a I did an article, I would say maybe a week ago, uh, maybe 2 weeks ago. I had to defend this one too because there was a lot of people that couldn't understand what I was saying about reality pretty much not being made of particles or matter, but actual energy fluctuations or wavelengths. And so,
But what reality?
our reality, our everything that you see right now,
This
yeah,
is not
made
real.
it made of waves, not particles. So
Mm.
fluctuations of energy, basically. So that's the same thing that we're talking about with the Casimir effect. So
So the only obviously yours is a hypothesis. This is something that you're wanting to voice and bring out there. You're not claiming that to be true, and we have to be careful with that. Like, I don't think you're saying this is a fact.
no,
Uh,
it's a study that I did. It wasn't my actual study.
yeah, for sure.
This is something that, of course, I'll read them in various science magazines, and I kind of break them down in those articles. That's what I post on the page each day. And so this was one that yeah, it confused a lot of people because yeah, I'm basically saying that reality, our planets, everything that you see, our stars, everything, they're not made quite of particles, but energy fluctuations and wavelengths. So that's something else that's being studied right now.
Yeah, that's gonna be a rough one to prove. It's gonna be so because everything physics is a particle.
Yeah, not quite. It's something that's moving pretty much. It's a science of motion. And that's why they say it's energy fluctuations, energy that's transforming into different forms, as well as the movement of that energy is what can make up mass. And if you think about it, it's the density of an atom that makes up a certain mass, right?
Yeah.
Or very or more than one atom, pretty much. And so those atoms are consistently moving. They're usually going in a cycle. Um,
Yeah, but like everything, I'm still stuck on it. It's a wave.
yeah, the wave is the actual energy and not the particle itself. So even particles themselves are made of waves or
Got
energy
it. Okay.
density.
Got it. Got it. But all matter is a particle. Like all matter is composed. Like it has got the particles.
Yeah, just saying that it
You're
goes even
saying that
smaller than that.
energy
Hmm.
particle isn't the energy. But I don't think anybody has claimed that. Have is that a claim that particles are energy?
No, it's the movement of the particle or the movement of the. You have the quarks, you have gluons, you have pretty much things that make up the particle itself moving around in that particle, and that energy fluctuation within that particle makes up the particle, which then makes up the mass.
Correct. Particles are not just pure energy in a literal sense. Rather, they are quantum excitations or ripples in fields that possess energy. According to modern physics, all matter, particles in parentheses, so matter is particles, is a form of energy, mass energy equivalence. E equals mc squared, and all particles have energy. They are best described as localized manifestations of energy. Um, Now this is where you lose me again, because one thing that just got brought to my attention from this is, yeah, E equals mc squared quite literally says that energy and mass is the same shit.
Hmm.
That's quite literally what it's saying is energy equals mass times the speed of light squared.
Right.
So it's um
So
yeah,
this one, yeah, I did write one. It's actually I posted it on March 31st
okay.
on my page. It says energy or the universe isn't made of matter but made of fields, basically energy excitations.
Yeah.
So
Yeah, that's an interesting conversation. And a lot of these conversations are, this is where I struggle is, and I've expressed this before in science, is we need new ideas. A lot of them are batshit fucking crazy. But again, I mean, Newton had to fucking prove all kinds of batshit crazy ideas and hypotheses and all that. They're batshit crazy until they're not.
right.
And not everything sticks, and not everything is. There's a lot of things that Newton did that we look back and like, that's what the fuck was he smoking when he said that, or where when he did that. Same thing with Einstein. Um, so, but also it just like this conflicts big time with classical physics,
Right.
which is not
But
a bad thing.
we have a lot to learn.
Well, if we know anything, and we do, is how absolutely little we know compared to what's out there. Um, Shit, even the stuff that we know, like the periodic table, they claim it to be complete. Some people say it's complete, and then other humans say it's we probably still don't know what the fuck is on Andromeda.
Mm.
Like there's probably shit out there that would fill up the periodic table even more so.
I mean, we haven't even reached the bottom of the ocean floor. So
Yeah, it's, well, we don't know much about the ocean. We know very little about the ocean for sure. So I'm with it, but yeah, crazy, 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 crazy. So the Casimir effect, um, it's another weird one. Actually, it's not weird. It just the way it's presented and what it does and how it does it is weird. The concept itself exists in shit that we see day to day. It just usually what we interact with is air and pressure
mm,
that that makes up that air. So higher pressure, lower pressures. Shit, this is how we get tornadoes. This is how we get. Um,
which
I like to drink. I don't know if you've ever done this, but I like to drink my water at room temperature, but my water dispenser is either fucking cold as fuck or hot. So I mix them, and every time I mix them, I get that. If I don't properly mix it, I get the hot water up at the top and the cold water down at the bottom,
oh,
just because obvious density differences.
right.
So we see this a lot. But the fascinating thing with the Casimir effect is it's being made out of virtually nothing. It's in a vacuum.
Yeah.
Yeah, that's
Yeah.
crazy.
Um, you mentioned tornadoes, and it kind of reminds me at a grand scale, similar to how a tornado would destroy a house. It doesn't, it what it does is it sucks all the outside air pressure
Correct.
away from the walls, and it causes the house to explode rather than implode.
Yeah, this is why they recommend. I don't know if it's still recommendation. I'm not. This don't fucking follow my advice. But they you do
Windows.
hear is open up a window, or again, I don't know if that's true. I think the MythBusters did something on it. I don't know which way it went, definitely do not use me as a source. But that was the idea: is if you open up some windows, leave a gap, it allows that pressure to leave. I mean, it's a fucking tornado coming towards your house. It's probably fucked either way.
I
Uh,
would just leave the house at that point.
yeah, I think at that point it just like you're splitting hairs on how fucked your situation is.
Right.
But I have heard is leave a door open, leave a window open, and that way the pressure equalizes a little bit more. Shit, it happens in planes too.
Hmm.
Happens in planes as well. They explode when there's a pressure difference. Now it's not as chaotic and as violent as people make it out to be, but there is a clear difference in pressure. Not too long ago, there was that lady that was kind of half sucked out of the plane because she opened up the window or something mid-flight, or a window flew out, and then she kind of got sucked out. So it happens. It can happen. So this is just another manifestation or another example on how, at a quantum level, in a vacuum, that force is still expressed out of essentially nothing.
Yeah.
Crazy.
Yep.
Crazy. I'm tapped out for this one. I don't know how much more you have.
Don't have much more. It's
Yeah,
a very simple concept.
it's a pretty simple concept. It's not as complex as I thought.
Yeah.
Uh, I did zero research on this. I didn't look it up. I just winged it. In fact, I was super late today because I didn't get home until about 6 p.m.
Oh,
So yeah, I didn't get much done. So, anyways, I hope this was, unless you have more words to say.
no.
No.
No. Mm.
I hope this was as interesting to you as it was for us. I know I learned some more stuff, and that's the goal with this is us learn about science and this really weird universe that we live in. There's this idea, there's this concept, there's this principle that we humans kind of take for granted how insignificant we are, and mostly it's because we don't understand how crazy this universe is.
Mm.
And I know for me it's helped kind of ground me on how trivial I could be, and how um I like it's not that serious. Like most things in life, like it's not that serious. Like if you just this shit is huge. Like the universe is huge, the earth is huge, the weird shit that's going on around you. Like I think if just people just were to understand how fascinating this world was and how it doesn't need you. And I don't mean that in a negative way. It's so difficult to say that and people not take it negatively. Like it just understand that most of the shit you're going through is all fucking trivial. Like most of your problems are like it's not even a fucking problem. Like it is in your head, but it's not even a fucking problem.
Yep.
But at any rate, I appreciate you guys tuning in. Those of you guys that jumped on, super duper appreciate it. If there's any corrections, anything else you want to add, this is how we learn. This is how we get better. Put them in in the comments. I have nothing else for the folks.
Yep. Um, I don't really have anything else, but yeah, these are just some cool little concepts just to learn about, just to research. Of course they've been researched, but yeah, I like learning about little things like this.
Yeah, absolutely, absolutely. Another good episode. I like it.
Yep.
I appreciate you guys. Have a good one.